So far, all of the problems that we've done in Chapter 10, Section 1 gave us the limiting reactant and told us which reactant was in excess. In Chapter 10, Section 2, we learn how to find the excess and limiting reactants for ourselves. So the excess reactant is the one that is left over after a reaction is done, so there's extra. And the limiting reactant is the one that's completely consumed. So this is the one that's going to limit how much of the other reactants get used and how much of the product that you could possibly make. So this one is really the key ingredient. This is the one that we use to start our stoichiometry problems. In general, you want your excess reactant to be the less expensive item of the two, so that you are not having extra leftover of some expensive ingredient that you can't use then. So, to find the limiting reactant, we can start with the cheese sandwich analogy. This kind of simplifies things a little bit. For our equation here, to make a cheese sandwich, you need 2 pieces of bread, 1 slice of cheese, and that gives you 1 cheese sandwich. Now here we've got 6 slices of bread and only 2 slices of cheese. So to make a proper cheese sandwich, you can only make 2 of those sandwiches, and we'll have 2 pieces of bread left over from that. So in this case, the bread would be the excess, and the cheese would be the limiting reactant. That would be what determines how much of the reactants we use and how much of the products that we can make. So now we're just going to add chemical names instead of cheese and bread. For this one, it says carbon monoxide combines with water to produce CH3OH. If you had 152 grams of CO and 24 grams of H2, what mass of CH3OH could be produced? So we need to write out a balanced equation first, since that wasn't given. So we have carbon monoxide combining with hydrogen, and CH3OH is our product. Now we were given grams for both of these 2 reactants, so that means that we need to find the limiting reactant. If you're only given grams of one of them, then you don't need to find the limiting reactant. That's telling you that the one that they gave you is the limiting. So we need to find which one of these is limiting, and then we need to find the mass of the product that we can make. So the first thing we're going to do is take the grams of each of the reactants that we were given in the problem and convert those into moles using their molar masses. So 28.01 grams per mole is carbon monoxide's molar mass, and 2.02 is hydrogen's molar mass. So that will tell us that we make 5.44 moles of carbon monoxide that we have present, and we have 12.1 moles of hydrogen present. Now we're going to take those, either one, and use the mole ratio between the 2 reactants to figure out how many moles of the reactant would be needed. So I'm going to start with the 12.1 moles of hydrogen and use the mole ratio from my balanced equation to cancel out the moles of hydrogen and convert it into moles of the carbon monoxide. That will tell us that I need 6.06 moles of carbon monoxide. Now, that amount of carbon monoxide is 6.06, and I only have 5.444 moles present. So I do not have what I need. So that means that the carbon monoxide is going to be the limiting reactant. If I were to have more than this 6.06 amount of carbon monoxide, then that one would have been the excess. I would have had extra left over. So now that we know that carbon monoxide is the limiting reactant, we're going to take our moles present and finish our stoichiometry problem, because we want to find out how many grams of the product we can make from that. So we're going to take our moles of the CO, use our mole ratio between the CO and the product, and then our molar mass of our product to find out how many grams of the product that we could make. So it's just finishing our stoichiometry problem. Now, theoretical yield is the stoichiometric calculation we've been doing all week, our grams to grams problem. Calculated maximum amount of product possible. This is what we should get if we were to do this experiment. The actual yield is the measured amount of product that we actually get during the experiment. So if we were to go conduct these reactions and weigh out our product, this is what we actually get. Our percentage yield is going to tell us how efficient our reaction is. So ideally, we want our theoretical and our actual to be the same value. We want 100% yield. Okay, if we have less than 100, that means we lost product along the way somewhere. If we have more than that, that means we gained product somewhere along the way. And we know that because of the law of conservation of mass, that should not happen. So there must have been some sort of error within our experiment. So here's an example of one of those calculations. When 0.835 moles of lithium hydroxide is reacted with excess potassium chloride, so we don't have to worry about finding the limiting, we're already told that this one is. The actual yield of lithium chloride is then 16 grams. What is the percent yield? So we want to find our theoretical yield. We're already given moles of our reactant, so we need to convert that into moles of our product, and then grams of our product. That gives us 35.4 grams for our theoretical yield. The actual yield was given to us in the problem as 16 grams, so we take the actual, divide it by our theoretical, multiply it by 100, and we get 45%. That's not a great percentage yield. Ideally, we would like it to be much higher than that, much closer to 100%.